Chapter 26 Sound by Sami Huseinovic, Dillon, Kraushaar, and Dallas Watson. The origin of sound. Sounds are originated in the vibrations of material objects. Some examples include pianos, violins, and guitars, which are all string instruments. When the first string is struck, it creates a more massive vibration through the sound bar. A sound bar is a material that sends a disturbance through a surrounding medium, usually air in the form of a longitudinal wave.
When sound waves are produced, the frequency of the sound waves equals the frequency of the vibrating source. This creates a pitch. The pitch is a subjective impression about the frequency of sound. There's high pitch, which is high vibration frequency, and then there's low pitch, which is low vibration frequency. There's infrasonic, frequencies below 20 Hz, and there's ultrasonic, frequencies above 20,000 Hz. Humans cannot hear either of these, but dogs and other animals can hear over 40,000 Hz and more. Sound in air. When someone claps their hands, it creates a sound wave that travels in all directions. There's a pulse that travels back and forth along the direction, similar to the spring that we did in class. There's compression, which is a pulse of compressed air. An example is when you open a door and the molecules get pushed out away from it. There's also refraction, which is a pulse of low pressure air. An example is when you close the door and the molecules move towards it.
In wave motion, the medium does not travel across the room, but the pulse does. As the source of sound starts to vibrate, a series of compressions and rarefactions travel outward from the source.
Media that transmits sound. Sound travels in solids, liquids, and gases. Solids and liquids are good conductors of sound, and you could hear sounds better in these conditions compared to the air. In a sealed vacuum, you cannot hear sound because the medium, which is not the air, is removed, so sound cannot travel.
This is an example of a vacuum removing air, which in this case is the medium. And before the vacuum is turned on, you can hear the music, but once the air is removed, the music decreases.
Speed of sound. Have you ever heard thunder after you've seen lightning? This example shows that sound is much slower than light. The speed of sound in a gas depends on the temperature of a gas and the mass of the particles in the gas. Water vapor and increased temperatures in the air increase the speed slightly. Sound speed is also increased in a gas that is composed of particles with a smaller mass such as hydrogen or helium.
In a solid, the speed of sound depends on the material's elasticity, not its density. Elasticity is the ability of a material to change its shape in response to a force, and then resume its initial shape once the force is removed. Elastic materials are composed of atoms that are close together, and they respond quickly to motion. Sound also travels 15 times faster in steel and 4 times faster in water compared to air.
Loudness. Sound intensity is proportional to the square of the amplitude. Sound intensity is objective and measured by instruments. Loudness is physiological and sensed by the brain. The decibel is the unit of intensity of sound. Hearing damage occurs at exposure of 85 decibel. Once damage occurs, it cannot be corrected.
Natural frequency. When different objects strike a floor, they could make a different vibration. Objects made of an elastic material vibrate in its own special set of frequencies, which make a special sound. Natural frequency is the frequency at which an object vibrates when it is disturbed. Natural frequency depends on the object's elasticity and shape.
Forced vibration. This occurs when an object is made to vibrate by another vibrating object that is nearby. Soundboards are important in stringed instruments because they are forced into vibration and produce a sound. Without a soundboard and acoustical guitar, the sounds would be very faint.
Resonance is a phenomenon that occurs when the frequency of a vibration forced on an object matches the object's natural frequency. This causes a dramatic increase in amplitude. Resonance also means to resound or sound again. An object resonates when there is a force to pull it back into its starting position and has enough energy to keep vibrating. An example of resonance is someone getting pushed on a swing.
Resonance occurs when successive impulses are applied to a vibrating object in rhythm with its natural frequency. An example of this is when in 1831 British troops caused a bridge to collapse by marching in rhythm, and now due to this, troops march out of rhythm when on a bridge. Interference. The crest of a wave corresponds with compression, and the trough of the wave corresponds to refraction. When crests of different waves overlap, there's a constructive interference, which then increases the amplitude. When constructive interference occurs, a listener will hear a louder sound. When the crest of one wave overlaps and the troughs of another wave, there's a destructive interference, which decreases amplitude. When destructive interference occurs, the listener hears a fainter sound, or often no sound at all.
Destructive sound interference can be useful in anti-noise technology. Jackhammers and other noisy devices are being equipped with microphones that send mirror image sound signals to earphones. These sound compressions or refractions become neutralized by the noise.
Beats. When tones of slightly different frequency are sounded together, this creates a regular fluctuation in the loudness of the combined sounds which is heard. This sound goes faint and loud over and over again. There's a periodic variation in the loudness of the sound which is called beats. An example of beats is when two slightly mismatched tuning forks are sounded together. These beats can be heard then. Each fork has a slightly different frequency from one another, so they will be in tune and out of tune with each other for moments at a time.
Yeah, 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 yeah. Oh, oh, oh.